Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the advantages of negative feedback, increased bandwidth. In the previous class we have seen the intro part of this topic, how the bandwidth is increased. In this class we will be seeing the derivation of lower cutoff frequency and higher cutoff frequency with negative feedback. In the yesterday class we have seen that the frequency response graph, the above one is without feedback. In this the bandwidth is coming to be between FL and FH, and the second graph is the frequency response graph for with negative feedback. So the FL is reduced to FLF and FH is increased to FHF. So FL means lower cutoff frequency without feedback, FLF means lower cutoff frequency with feedback. The difference between FH and FL is known as bandwidth. Similarly, the difference between FHF and FLF is known as bandwidth with feedback. So from the frequency response graph, what is the frequency response graph? It is a graph between gain versus frequency. Where the gain is constant, we say that as A mid, gain in mid range. From the constant gain, if we are taking 0.707 times of A mid and locate that in the graph, that point is known as FL, the lower cutoff frequency, and we draw like this the dotted line. The line which is touching on the higher frequency region is higher cutoff frequency region. Okay, so in this way we can find the bandwidth of an amplifier. This is without feedback and is also known as open loop, and the second graph is with feedback. So from the graph it is clear that bandwidth with feedback is greater than bandwidth without feedback. Mathematically the equation is bandwidth with feedback is equal to bandwidth dot 1 plus A beta. So BW means bandwidth without feedback is multiplied by the factor 1 plus A beta. So definitely bandwidth with feedback is increased. Okay. So now coming to the derivation. Before start of the derivation, let us quickly revise all the formulas once again. The gain of an amplifier with negative feedback is given by AF is equal to A by 1 plus A beta. And this frequency response graph is having three regions: mid band region, lower frequency region, and higher frequency region. Similarly, we will have having three gains: A mid, the gain in the mid band is known as A mid, gain in the low frequency band is known as A low, and the gain in the high frequency band is known as A high. So we are having three gains: A mid, A low, A high. So these are without feedback. Now when we want to find with feedback, we have to take the reference of this one. If you are writing for mid band, how do we write? AF mid is equal to A mid by 1 plus A mid beta. If it is for A low, what will do? Gain with negative feedback, AF low is equal to A low by 1 plus A low beta. Now for high frequency, AF, F means with feedback in the higher frequency region, AF high is equal to A high by 1 plus A high beta. Okay, so A low is the gain in the low frequency region without feedback, and AF low means gain in the low frequency region with feedback. A mid, AF mid, A high, AF high. So what will be AF low? A low by 1 plus A low beta. Now coming to, let us now see what is the lower cutoff frequency. So what is the lower cutoff frequency? From this graph it is clear. From the mid band, if you descend to the point of 0.707 times of A mid value and locate that point in the graph, that is known as lower cutoff frequency, and when we take this in the higher frequency region, it is known as upper cutoff frequency. So now we have to find what is the relation between FLF and FL, FHF and FH? So first we will see lower cutoff frequency derivation. So FL is what? Lower cutoff frequency without feedback. FLF means lower cutoff frequency with feedback. Now we have to see what is the relation. Let us start with lower cutoff frequency. So as we know, the relation between gain at low frequency and gain at mid frequency, low and mid, the relation. This is without feedback. We know this relation, A low by A mid is equal to 1 by 1 minus j FL by F. This is the equation we know from the frequency response graph of an amplifier. This is without feedback. So now let us write what is A low equation. If you take A mid here, A low is equal to A mid by 1 minus j FL by F. What is this equation for A low? This is without feedback. Now when we want to write this equation for with feedback, what we will do? AF low. AF low is equal to A low by 1 plus A low beta, because it is a negative feedback, A by 1 plus A beta. So AF low means A low by 1 plus A low beta, and we know what is A low. What is A low? A mid by 1 minus j FL by F. Now coming to the denominator, 1 plus A low. Now substitute A low. What is A low? A mid by 1 minus j FL by F times of beta. So I have substituted A low. Now on simplifying, so what happens now? This comes into denominator and this is multiplied by 1. A mid by, this denominator is multiplied by 1. So it will be 1 minus j FL by F plus beta times of A mid. Okay. So we got this equation now. On rearranging the terms, A mid by 1 plus beta times of A mid minus j FL by F. Okay, now divide the numerator and denominator by the term 1 plus beta A mid, that is A mid by 1 plus A mid beta, divide by 1 plus beta A mid divided by 1 plus A mid beta minus j FL by F by 1 plus A mid beta. So what is this equation now? If you are familiar with gain with feedback, A by 1 plus A beta is AF. So it is A mid by 1 plus A mid beta. So it will be AF mid. This is written as AF mid, and this becomes 1 minus j FL by F by 1 plus A mid beta. So now if we write the equation, this equation we are writing it like this: AF mid by 1 minus j FL divided by 1 plus A mid beta is taken as FLF, okay, divided by F. So now we are writing this equation as AF mid by 1 minus j FLF by F. So what is FLF now? FLF is equal to FL by 1 plus A mid beta. So what is FLF here? Lower cutoff frequency with feedback. It is equal to FL by 1 plus A mid beta. So we are getting the equation now. This is for AF low. AF low is equal to AF mid by 1 minus j FLF by F. And what is this FLF? FL by 1 plus A mid beta. Now bring this AF mid to here. So it is written as AF low, that is gain in low frequency with negative feedback divided by gain in mid frequency region with feedback. A low by AF low by AF mid is equal to 1 minus j FLF by f. Okay, so if you now look at these two equations, what is this one? A low by A mid. So what we got the equation? A low by A mid is equal to 1 by 1 minus j FL by F. This is what the ratio of gain in low frequency by gain in mid frequency without feedback. Now after applying negative feedback, the equation becomes, this becomes AF low. F means with feedback. AF mid, gain in mid frequency region with feedback, becomes 1 minus j FL F by F. This is with feedback. So this is the equations we got in lower cutoff frequency. So what is FLF now? FLF is the lower cutoff frequency with feedback. Lower cutoff frequency with feedback. How much is the equation you are getting? FLF is equal to FL by 1 plus A mid beta. Okay, so this FLF is what now? Decreased. Why? Because it is FL divided by some factor. So FLF is reduced. Now coming to upper cutoff frequency region, as we have written for the lower cutoff frequency, A low by A mid. Now what we have to write for upper cutoff frequency? A high by A mid ratio, which is coming to be as 1 by 1 minus j F by FH. Here what was the equation? 1 minus j FL by F. In lower cutoff frequency, FL is in the denominator. In upper cutoff frequency, it is F by FH. So A high by A mid is equal to 1 by 1 minus j F by FH. So now take this A mid here, which is written as A high is equal to A mid by 1 minus j F by FH. Now we got the equation for A high. Now we have to write this equation for AF high, that is with feedback. So what will be AF high? AF is equal to what? A by 1 plus A beta. So now this is AF high, so it will become A high, A high. So AF high is equal to A high by 1 plus beta A high. Okay, so this is the equation. Now write what is A high. We are having this A high here. A high is equal to A mid by 1 minus j F by FH divided by 1 plus beta A high, 1 plus beta A high. A high is equal to A mid by 1 minus j F by FH. Okay, now we are writing the equation for AF high, which is equal to A mid. Now multiplying this with the numerator here. A mid 1 minus j F by FH plus beta A mid. So we got the equation like this: A mid by, on rearranging the terms, 1 plus beta A mid minus j F by FH. So now divide the numerator and denominator by this term. So AF high is equal to A mid by 1 plus beta A mid. Now coming to the denominator, 1 plus beta A mid by 1 plus beta A mid minus j F by FH, minus j F by FH divided by 1 plus beta A mid. So now writing for the AF high is equal to, what is this equation? A mid by 1 plus beta A mid. This equation is for AF mid, which is equal to this, on cancelling, this is AF mid, this is 1. So it became AF mid by 1 minus j F by FH by 1 plus beta A mid. On rearranging the terms, we are getting AF mid by 1 minus j F by, this FH is coming down here, FH dot 1 plus beta A mid. On rearranging, when we take this term FH 1 plus beta A mid as FHF, we can write the equation of AF high is equal to AF mid by 1 minus j F by FHF. Now we can write this equation for AF high by A mid. Now bring this A mid here, AF mid here. So we are left with the equation 1 by 1 minus j F by FHF. So what is FHF? Upper cutoff frequency with feedback, which is coming to be as FH dot 1 plus beta A mid. That is, FH is what? Frequency in upper cutoff region, upper cutoff frequency. We say FH is what? Upper cutoff frequency without feedback. E is multiplied by certain factor. So definitely FHF is greater. So upper cutoff frequency with feedback E is greater than upper cutoff frequency without feedback. Okay. Now what is the equation of bandwidth? Bandwidth is equal to, bandwidth with feedback is equal to higher minus lower. So with feedback, BWF is equal to BHF minus BLF. What is FHF? FHF is equal to 1 plus A mid beta times of FH. FL is reduced. So it is FL by 1 plus A mid beta. So FHF is increased. So what is the equation? FH dot of 1 plus A mid beta. FL is reduced. So it is FL by 1 plus A mid beta. So what we observe in this derivation, that the bandwidth with feedback is greater than bandwidth without feedback. So the negative feedback increases the bandwidth of an amplifier, hence the range of frequencies which can pass through the amplifier is increased. So this is the derivation. I hope it is clear. Now what we have written? A high by A mid. What is A high by A mid? It is equal to 1 by 1 minus j F by FH. Okay, now this is without feedback. This ratio is without feedback in upper cutoff frequency. Now if we write the same equation for with feedback, it will be modified as AF high by AF mid is equal to 1 by 1 minus j F by FHF. This is with feedback. Now what is FHF? It is upper cutoff frequency with feedback. How much is the equation of FHF? Is equal to FH times of 1 plus A mid beta. So FHF is greater than FH, and here FLF is less than FL. Okay, so less means divided by, FL divided by 1 plus A mid beta. FHF is increased, so it will be FH dot of 1 plus A mid beta. So, this is a summary of the derivation. It is easy to remember actually these equations. The ratio A low by A mid 1 by 1 minus j FL by F. Coming to high, what happen? A high by high A mid ratio 1 by 1 minus j F by FH. Here FL by F, it is F by FH. After finding this ratio, find the ratio with feedback, that is this FL will change to FLF. Here this FH will be changed to FHF. FHF is increase, so it with the final equation it is easy to remember. Increase means it will be multiplied, FH multiplied by 1 plus A mid beta. FLF is reduced, so it is FL divided by 1 plus A mid beta. So, bandwidth with feedback is greater than bandwidth without feedback. This is the equation you can remember, is bandwidth is increased. So, with what value it is increased? Bandwidth 1 plus A beta. I hope the derivation is clear. If you have any queries, you can post in the comment section. Thank you. Good luck, students.